Hey guys, welcome to my channel and I'm back again with another really interesting video. As you can see on my screen guys, today we are going to experiment with multi-modality with the help of Google Gemini Pro and Pro Vision model and with LlamaIndex to create RAG pipelines that can actually use images as a context for answering your questions. So I know this video is going to be really interesting for you. So without taking any time further, let's get started. So first of all guys, in this notebook we are going to actually do 3 tasks. Firstly, we are going to see how we can use Gemini and Gemini libraries in LlamaIndex for answering your prompts or list of images, and also how we can create the answers in a stream. Then we are also going to start to output structured results on our queries on multimodal data. And then the last part is we are going to build a Retrieval Augmented Generation Flow, that means a RAG pipeline for a Google Map restaurant dataset. So let's get started now. So first thing first guys, whenever you are trying to experiment with this, you need to install certain libraries. And this is a list of libraries we are going to install. We are going to have LlamaIndex Multi-Modal LLMs Gemini for our multimodality, for handling the images. Then we need LlamaIndex Vector Stores Quadrant, because as I told you in the last section, we will be building a RAG pipeline. So we need vector stores for that. We need embeddings also. That's why you need LlamaIndex embeddings. And we also need LlamaIndex LLMs Gemini, because we want to use Gemini's text model as well, not just multi-modal but text model also, to actually work with our data. Okay, so let's get started now. Let's go a little bit, let's not scroll that much, let's go scroll a little bit, right? So first thing is use Gemini to understand images from URL. And whenever you want to actually work with Google Gemini guys, you need a Google API key. So this Google API key you can actually fetch from Google AI Studio. So as you can see on my screen, I have Google AI Studio open in front of me, and you can click on get API key here that I have clicked, and you will get your API key like this, and you can click on that and copy that API key. Once you have copied that API key, I would actually recommend, if you are using Google Colab, to put that API key in your secrets here. And when you select it this way, you will actually enable your Google Colab notebook to use this key. And then what I have done is I have simply fetched my secret from the Google Colab using userdata.getGoogle. And then I have made it as my environment variable. And now this is going to work because all the Google Gemini's modules actually refer this environment variable. Now the next part is to initialize the Gemini multi-modal and load the images from URL. So now that we have the API key, it is time to actually start working with images. So for that, we need the images, right? So this is one sample URL, but you don't even have to use this sample URL which is from storage Google APIs. You can actually upload your own images. So if you go to folder here, you can actually upload your own images here, and you can add the relative URL of that folder here, and even that is going to work. But here we have used this storage googleapis.com. All you need to do is, once you have your image URLs with you, you have to call this function called as load image URLs. And this function is also imported from the LlamaIndex library, which is the multi-modal LLMs library. Now once you have the image documents with you, it is time to use it. But you not only need your image documents to start asking questions, you need your large language model as well. One thing we did before is we got our API key, but we also need to have a large language model. For that, we are going to initialize the Gemini multi-modal class object, and here we are going to set the model name as Gemini Pro Vision. Why we need Gemini Pro Vision guys? Because Gemini has got two models, Gemini Pro, which is a text model, and Gemini Pro Vision, which is a text and image model. So you can basically ask it questions on images and on text. We are going to work with images, so we are using Gemini Pro Vision. So now you have successfully initialized your LLM and your data that you want to query on. Next part is we are just, so this code you don't really have to understand. This is just a boilerplate code for actually loading your image and showing it to you on your Google Colab. So this is just rendering that image that I just showed you. Okay, and you can see that this is basically a city scene, and now we are going to ask questions on this city, right? So if you want to ask questions, you want to add a prompt with this LLM, the Gemini multi-model class object, there is a function called as complete. So in this complete function, you mention two things. One is your prompt, and second is your data, your image documents. So you can see that I have passed here the prompt, identify the city where this photo was taken, and my image documents are just a list of images that I have loaded from the URLs. And when I print the complete response, it successfully prints New York City, and in a very clear and concise manner, it prints that it is New York City, right? Now, this is the way when you want to get your answers, very quickly. But there are certain ways, some summarization tasks where you want to actually stream your response, because the response is so huge that you just want to stream over it. You want to create an iteration of it, and you just want to start printing the response as soon as you get it, right? So for that we are using a stream API, and for that the method is called as stream complete, not complete but stream complete. So you don't get the full answer in one go, but you do get an iteration, like a stream of responses that you can print one by one in a for loop. So again, the prompt is give me more context for this image, and then you pass your image document. So this streaming is mostly done for this context or summarization or like longer answers, not for one word answers. And then you iterate over it and you actually print the text of the stream. And it basically prints a lot. This is the alleyway in New York City. It is a narrow street, blah, blah, blah. It describes the image. It is made of brick, lot of windows, and it basically prints many sentences that you have iterated. So now this is how the stream works, and this is how the complete response works. But you might have noticed that the image document that I was passing in this complete function is actually a set of images. It is not a single image. Obviously we use a single URL, but if you pass multiple URLs, so you can see that I have two URLs mentioned here, and if I pass both of these two URLs, so one is the image of Lionel Messi and one is the image of this place in Rome, and now I can actually compare these two images with the help of Gemini Pro model. So all I have to do is Gemini Pro.complete, and the prompt is there any relationship between these two images? And then you can pass a list of documents. So you can do that as well. You don't have to just stick to single image. We can pass multiple images. And then it actually prints very correctly that there is no direct relationship between two images, but they are both related to the city of Rome. The first image is of Lionel Messi, as I told you, who plays for Paris Saint-Germain. Obviously guys, this model is not yet updated with the latest information that Lionel Messi has actually left this club and is now playing for some other one, but it still needs a little bit of realistic information to be trained on. But at that point of time, when he was still in PSG, this information was fairly correct, that he used to play, and now he's also playing for Argentina national team, greatest footballer, and blah blah blah. And it is then explaining the second image, which is of Colosseum, and it is one of the most popular tourist destinations in the world. So in a way, both of these places are both of these things are world famous. One is a human who is a world famous human, one is a place which is world famous. So this is a sort of an indirect relationship between them, but other than that, they are not directly related. But you can see how successfully we are able to completely compare two images. And you can have even more than two, right? So you can load more images if you want to. And now we know how you can easily use your Gemini model and your LlamaIndex libraries to actually ask questions from the images, describe the images or summarize them, right? Now it's the time to actually get a structured output from the image. Now, if you have not followed my video of structured output, I would actually highly recommend to go and watch it, because in this video we are not going to discuss the structured output in detail. But basically, in this case, we want our response in a proper JSON format. We don't want a text response, we want a JSON structured format. Now, again guys, you can see that we are using Google Gemini for the image reasoning, and for structured output we are using a library called as Pydantic. Okay, now we want to have certain things configured. But you can see that we will configure that later, but right now you can see that what we have done is we have imported Google Generative AI. We are configuring the API key, certain client options. But what we are trying to do is we are trying to print what all Gen AI models we have available. So this doesn't really matter right now for us, because we know we are going to use the Gemini Pro or Gemini Pro Vision model. But if you want to print and find out what all models your REST API has access to, this is the way to do it. You provide your API key, provide your endpoint, and then it prints all the models it has access to. And this gives you a good idea of how you can actually use these models. So you can select any one of them basically, and then you can use it, right? So now we know what models we can use. It is time to actually also download the images that we want to use as a context to generate a structured response or to query our questions from. Now again, I told you and I'm telling you guys again that you don't need to actually download the images from somewhere, which we are downloading it here. You can actually just have the images and you can upload it in a folder here in Google Colab. But what we have done right now is through code, you can see that we have imported the path library here, and through code we have created a folder called as Google Restaurants by using path.mkdir. So that's how this folder got created. And then we are downloading all these 4 images for different Google restaurants, and then we are taking all the PNG files and we are storing them in this Google Restaurants folder. So now Google Restaurant, if I actually see it, it has got multiple PNG files, and all of the PNG files we actually downloaded it. But you don't have to use this code, you can actually download your own and you can just upload them. Now we are still trying to use Pydantic class to actually define what we want to see in our data, okay, or what do we want to see in our response. We have the data with us, but what type of response we want to see from that data. For that we need to create a class that has a structure for us. So we want to generate a structured response, but we need a class that can define that structure. And what you do is you actually import a base model class from Pydantic, and then you create your own class. Here we are creating a class called as Google Restaurant that is actually inheriting the base model class, and these are all the attributes that we want to see in our structured response of that Google Restaurant. Let's say if I have the Google Restaurant image and I want to query what type of restaurant it is, or I want to have some questions about that response, about that restaurant, then it is going to give me all these attributes of that particular restaurant, okay? And that's why we create this Pydantic class now. Now it's pretty straightforward from here. First thing is we are going to take one of the image, we are going to open it and we are going to show that image or render it that image here, and we just want to see what all information is there in that image. You can see that this image has got the name of the restaurant, certain directions of the restaurant, the location of the restaurant, and it has also have got the opening time, closing time, blah blah blah. And all these attributes are actually part of the class that I created, restaurant, food, location, category, etc., the price and the hours, etc., right? So all that information is present in this image. All we need to do is fill that class object with that data. And how we are going to do that? We are going to do that with a custom method that we will create, and that custom method is called as Pydantic_Gemini. Now ignore the code which is above, guys. Let's try to first understand this main method here, which is going to do the job for us. This method takes few arguments. It takes the name of the model, takes the output class. So output class is the structured class that we want to fill with all our response attributes. And in our case, it is going to be Google Restaurant. Then we have got our image documents, which is again the images that we are going to load from our Google Restaurants folder. Then we have our prompt template string. Okay. Now this prompt template string is nothing but the question that we want to ask from our image, and we are also hard coding this prompt template string over here, where we are saying that can you summarize what is in the image and return the answer to us in a JSON format. So that's what this prompt template string is about. And now all the libraries that we will be using in this function are actually imported from all the LlamaIndex APIs. Okay, and we will be using them one by one. The first thing first is we have our model name, right? So let's say my model is Gemini Pro Vision. But we need to take that model and we need to create a Gemini multi-modal object with it. So here is the code for that. Gemini LLM becomes equal to Gemini multi-modal. We provide the API key, we provide the model name. Okay. Now we create a object called as LLM program, where we actually do multi-modal LLM completion program dot from defaults. So think of it in that way. This multi-modal LLM completion program is sort of like a pipeline. If you guys know, have been following my videos, are a little bit familiar with transformers and how the transformers pipeline get created. A pipeline is a way, it is like a program only, but it has got many steps to it. And all these steps, you can provide that as an arguments, and you can provide the information or the data that is needed for those steps to complete as an argument, right? For example, in a pipeline, you can define that this is my model. You can define that I am going to use this embedding. I am going to use this token vectorizer. I am going to use this prompt template. I am going to use, these arguments or whatever. So you can think of a pipeline as a set of steps that you can define, and also the data that is needed by those steps. Okay. So same thing is this multi-modal LLM completion program, where we are defining all the steps that we need and the data that is needed by those steps. So now you can see that multi-modal LLM completion program basically has got few arguments, which is nothing but the data that needs to complete those steps. So the first thing this thing needs is an output parser. And by output parser, it now knows that whenever I will return the output, it is going to be formatted in a certain way. And the formatter is nothing but your Pydantic output parser. And inside the constructor of this class, you will pass your output class, which in our case was Google Restaurant, that was importing the Pydantic base model, where you define all the attributes that you want in our response. So that becomes your output parser. This gives it the idea that I cannot just return the output as a text, I need to parse it, format it. Then you pass your image documents, pretty straightforward. This is the data that you need to work on. You pass your prompt template, pretty straightforward. This is the question you are asking. Then you pass your multi-modal LLM, which is your Gemini LLM. Again, pretty straightforward, that this is the model that you use to answer your prompts. Finally, you keep the verbose equals to true, just because you want to actually see what's happening while you are getting your response. And when you have this completion program created, you just use it as a function to call, and whatever response this function produces is your actual response. Okay, so this is your Pydantic Gemini function. That's a custom function that you have created. Now, how do we use this? The first thing is you actually create an object of simple directory reader, which is nothing but a directory reader, as the name suggests. It is going to read from this Google Restaurants directory, load the data, and here you will get your image documents, right? For now, each and every image in this image document, you are going to call that Pydantic Gemini function, which is going to return you a structured output. And you can see that we are passing all the arguments we defined here, the model name, the output parser, the image document, and the prompt template. Now, once we get our response, it is going to print that response. But our condition is that we don't want the response for all the images. We only want to check if the image has got Miami in it. That means if the restaurant is from Miami, then we actually print the response. So for all the responses in Pydantic response, we print the response, and then we append our response in our result, and we finally get the results object, which is going to have all the results, right? So this is the results object. So results object will have the result for all the restaurants, but we are only printing the result which is having the Miami name in it. That means we only want to print the restaurant which are from Miami. Let's assume that, right? So now you can see, and let's scroll it up. when I actually run this code, it actually does return me a JSON output. So this is my JSON output. It looks a little bit weird after this because we have set the verbose equals to true. But if you just want to see the actual response, which is a JSON response, you can see that it prints it, and it only prints this response because this object has, Miami in it, and then it not only prints the name of the restaurant, food location, it also prints the nearby tourist places, which is this. Now, if you look at the image here, you can see that there are no nearby tourist places mentioned in this. How is it able to recognize that? Because Google Gemini model is so sharp that it can actually read the Google map, and it can very easily find out what are the nearby tourist places just by looking through the map image. So that's how efficient it is. So that is why, guys, you can see that when you render the nearby tourist places, it gets you a lot of things. Okay. So that's how you can use Google Gemini to create your structure response and Pydantic. Okay, so that's the observation, right? It perfectly generates all the data you need, all the metadata, and it also recognizes the nearby places. So that means that we can use Google Gemini for a bigger purpose now. That means it's so good that we can actually use it to create a recommendation engine where, let's say, if I am in Miami and I want to know what are the recommended places for me to eat, some recommended restaurant, I can actually use this RAG pipeline. I can actually use this model, let's say in a smaller terms, to find out what all restaurants are nearby me which are good to have food, or what all nearby tourist places I can also visit, right? So this is our third and final part where we will use these structured output abilities, LlamaIndex and Gemini, to do the same. So the first thing is that now that you have the structured output, now that you have a list of results with you, all having the JSON value, it is time to put all those results in a vector index. How do we do that? First of all, you create a text node, which is the LlamaIndex core schema object. You iterate through all the results, you create a text node, okay, and then you create a list of nodes where you simply just append all the nodes in that, right? And here we are also setting the text node dot text becomes equals to R1, where basically we are saying that the text node text will become equals to the description of the result. So this is a little bit of boilerplate code which I don't want to go a lot deeper into it, but basically, guys, when you create a text node, you have to fill it up with text, right? So you create a text node for each and every result, and for the result in results, you will simply find out the description, and you will set the description as that of the text node text. And if the first result does not have a description, then you will simply set the metadata of the first node as the second result. Okay, it's a bit elaborate, don't get too much into it, but basically you are trying to create a text node where you definitely need to have a text value set, and you need to have a metadata value set. So basically you think that your text is the name or the description of your restaurant, and the metadata is the rest of it. Whatever things are left, that's the rest of it, and that becomes your metadata. Finally, you append your text node to your nodes, and then you get a list of text node. Now we need to have Gemini embeddings, and we need to have a vector store. Now these are certain libraries that I imported myself again because the quadrant library was not working as I expected. So you actually need to import something called as LlamaIndex vector store quadrant instead of the library which you previously created. Then you need a readers file, and then you need a embeddings as well. Okay. But these imports which I did, after the first one, they worked for me. But if you go with the original first 4 imports, it will throw you an error. So you need these ones. Now we go to the meaty part. We actually create our quadrant vector store here. So you can see that these are all the things that we have imported. We have our vector store, index, storage context, embeddings, vector store, quadrant vector store, storage context, blah blah blah, right? So these are just the imports. First thing is we create our quadrant client. When you create your quadrant client, guys, you provide it a path. This path is, so let's say this is the path here. So first of all, when you run this line, it is going to create a folder here, which is quadrant Gemini _4. Now this folder will have a collection. It is going to have basically all the vector store data, all the index that you have created with your text node. It is going to be stored here. So now you create our vector store, you pass your client, you pass your collection name. So it is going to create now a collection folder. Now you need to also create your embeddings, because whenever you have your text data, you need to convert it into a vector. You need an embedding model. So here we are using a embedding 001 model, providing the API key as the Google API key. Then we also set our LLM to be the Gemini model, where the model is Gemini Pro. Now remember this one thing, guys. Now we are working with text. We are not working with images. So when you are not working with images, you don't use the Gemini Pro Vision model. You create your Gemini Pro model object and not the Pro Vision one. So this is a very important point. Next thing is you create your storage context, where it is just a container where you have your vector store, and that vector store you have defined before. Now you create your vector store index, where you actually put everything together. You put your vector store here, which was encapsulated under the storage context. You put all your text nodes here. So once you have created your index and then you run this command, basically this quadrant Gemini 4 will have this collection folder filled with a file called as storage SQLite, which is nothing but your storage context created, which is having the index of all your text nodes. Okay. And now that you have an index of all your text data created, it is now time to use that index as a query engine. So now you can fire queries in that index and you can get your response pretty quickly. So all you have to do is do index.as query engine. Similarity to op k = 1, because whenever you want to query, you don't want all the results, you want the top one result. You can obviously increase this value, but you want the top one result. And your question is, recommend an Orlando restaurant for me and it's nearby tourist places. And you can see that it prints the response. Then Mythos restaurant is the recommended restaurant in Orlando, describes the restaurant, and it also says the nearby tourist places includes Universal Island of Adventure, blah blah blah, Volcano Bay, etc. etc. So you can see here, guys, that with only a few lines of code, you were able to have your images. You were able to parse those images into a structured output, and not only that, you were able to create a query engine that can look at the Google Maps of those images, find out the nearby tourist places, and create a recommendation engine for you. So there you see, guys, you can see how powerful this Google Gemini is, that how good its image recognition functionality is. And that is why I highly recommend you guys to use Google Gemini for all your image recognition and all your image parsing techniques. Now, one thing to be noted, guys, that the API key that I used here, you can get it for free from Gemini, definitely, but it is limited to a certain number of requests. So if you are some developer like me who just wants to experiment, play around with stuff, create few apps just for fun and for educational purposes, you can do that. But other than that, better to have a billing account created, because otherwise you will fall into the limit exceeded bit and you might not be able to have your application alive for a longer time. Okay. But that was the video, guys. The video became a little bit longer than I expected it to be, but it was needed to explain you how you can experiment with multimodality and with the help of LlamaIndex, how easy and fun it is to do so. So I hope you guys liked this video, and I hope it became a little bit informative for you in some way. If it did help you in your life, guys, then please do not forget to like this video, share this video with your friends. If you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. And guys, if you have any questions, comments, suggestions, feedback for me, please do write down in the comment section below. I would be really happy, and the community also will be really happy to read them out. So thank you so much for watching. I'll see you guys in the next video. Until then, take care and bye bye.